alert element, so you should make sure that you add an import to that. So import alert component from, and now it's alert component. And down there, of course, it should also be alert component. Element is the name of the constant, but we pass in the component to create custom element. Now, create custom element also needs a second argument. This argument is used to configure this element. And there we need to pass the injector we're using. Now, Angular uses dependency injection, as you know, and the injector is basically the tool which does this injection, and we provide it to this custom element so that the element behind the scenes is able to connect itself to our app, so to say. Therefore, we simply inject the injector. So import injector from @AngularCore, and with that injected, in that object you're passing to create custom element, you add the injector key, and as a value, the injector you're injecting. That's a lot of injection going on, I guess. So with that, we created a custom element, and this indeed already is a native web component. Now we can use the custom elements API, and important, this is not an Angular feature. This is a feature provided by JavaScript and called define there. This allows us to register a custom web component. And again, alert element is just such a component. It's the same as we could have built on our own. So therefore here, we first of all define the tag by which we want to select it. And this doesn't have to be the same one as down here. So we could also use my-alert, for example. And then you pass in the element. So not the component, but alert element. So our custom element. Now with this, we can use that. So down there, I use my-alert instead of app-alert because I changed the tag. And now if we save this, it compiles, and if we go to our application, nothing happens. But if we inspect the console, we actually got an error that that doesn't find a component factory. Now, as I said, Angular elements are only available in Angular apps right now. So what we have to do at this point of time is we have to add the entry components array to our app module. Entry components essentially is an array of components which you don't use with its selector or via routing, but where you want to tell Angular that you're eventually going to use it. And this is exactly what will happen for the alert component. We declare it, that's important, so that Angular can find it, but we also need to tell Angular, hey, you won't see me use a selector for this. You won't see me load it with routing, but eventually I will need it. So please be prepared to load it when I need it. And that is why we also have to load the Angular component, the alert component, not our custom element, but the Angular component here, into our entry components array. And if we do that and we save, the app will reload and we get at least a warning, not an error. Sanitizing HTML stripped some content. Now, the custom element is in the end a bunch of JavaScript code. And this is sanitized, so this can't be rendered with inner HTML. That's a security mechanism to avoid cross-site scripting attacks. We want this mechanism, but in this case, we know our content is safe, and therefore, we want to be able to output it. We can do this with the help of the DOM sanitizer. You can also inject this. It's the DOM sanitizer object or class, which you need to import from @Angular platform browser. And with it injected, you can wrap this custom HTML code, which again, behind the scenes will use a lot of JavaScript. You can wrap this with DOM sanitizer bypass security trust HTML, so that this HTML code and whatever is connected to it is trusted. So now with that, if we reload this, we do see our alert after a second, but this time it's loaded as a custom element. If we inspect it, we see our template here and we see the styles we applied to it, but this now actually is loaded as a native web component. Still only usable in Angular projects. This will probably change in the future though, but already useful for dynamic content like this. Since we sanitize it, you should of course make sure that you know that this content is safe. But with that, you got a really great tool to load content into your app and control it as an Angular component and do all the fun stuff you can do with components whilst getting it from another source which is not hard-coded into your Angular project code when you're compiling it. Now, that's it for this course. I hope you enjoyed it. I hope you got a lot out of this course, and I can only encourage you to keep on learning. Don't stop here, because taking a course is great. And I got more courses if you want to dive deeper. But if you want to master something, if you want to get really good at something, you have to apply what you learned. You have to use it. Use it in your day-to-day projects. Build demo projects where you apply what you learned. Make sure that you don't lose that knowledge, because taking a course gives you that solid foundation, but you only become good at something if you then use that foundation to use it in your day-to-day work, in your everyday work, in your projects. And therefore, I would of course love to see you in other courses, but either way, I wish you all the best for your future. Now, this course section is optional, because this course section will act as an introduction to TypeScript, the programming language which we are going to use throughout this entire course, since Angular embraces TypeScript. But TypeScript, in the end, is just a programming language extending JavaScript. So if you know JavaScript, learning TypeScript is rather straightforward, and you should be able to learn those key TypeScript features by simply going through the course step by step. Nonetheless, in this course section, if you want a quick introduction to TypeScript or you want to have a summary of the core features, I will introduce you to what exactly TypeScript is and why we might want to use it, what its benefits are. And we are going to explore some of its key features and types, which we use all the time. Now, that being said, we will not cover every single TypeScript feature which you see in this course, since you will learn it step by step when going through the course, as mentioned. So, what is TypeScript and why would you use it? TypeScript is a so-called superset to JavaScript. It's a programming language which builds up on JavaScript. It extends JavaScript, you could say. And that is really important. The core programming language still is JavaScript. So the base JavaScript syntax, you know, how you write JavaScript code, if statements, for loops, objects, all that does not change. But TypeScript then adds more features to the JavaScript syntax. And most importantly, it adds static typing to JavaScript. And that's also where the name comes from, TypeScript. It adds static typing to JavaScript, because JavaScript on its own is actually dynamically typed. And what does this mean, and why is this useful? For this, I prepared a very simple example here, which you find attached. Now, this is not an Angular project. That's a standard empty project, basically, with just an HTML file and a JavaScript file. And I prepared this project to show you why we might want to use TypeScript and why Angular, in the end, uses TypeScript, therefore. This is a standard JavaScript function and a standard HTML file which has no actual content, but which imports this script file. Now, if I open this file in the browser, simply by copying the path here and then opening that path in the browser, if I reload this page and open the developer tools, I see 7 here in the developer tools in the JavaScript console. And I see 7 here because in this script file, I define an add function, and then I call this add function and store the result in this constant, and then I log this constant. So that's standard JavaScript, nothing fancy here. Now, JavaScript has types. JavaScript knows the concept of types. For example, here, the 2 values which I'm passing in are of type number. And that's something JavaScript knows on its own without TypeScript. The important thing just is that JavaScript, as I just mentioned, is dynamically typed, which means that this function here does not expect any particular types. It just knows that it will receive 2 parameters, and that's it. So it's not statically typed. The types for this function are not announced ahead of time. Instead, it just takes whatever it gets and then tries to execute this code. And that code happens to work with numbers. But this code also happens to work with strings. And hence, if I convert my 2 numbers into strings here by wrapping them with quotes, then I got 2 different types here. I got 2 strings instead of numbers, which are types JavaScript knows. And if I change it like this and save this file, if I reload, you see now we get 25 here. Because now the plus operator does not add these 2 arguments in a mathematical way, but instead it concatenates 2 strings because it receives 2 strings here. And that shows why just JavaScript is okay and great, but why it might not always be best. Why having static typing could enhance your code and prevent errors like this. Now, of course, you might say, which error? I can simply not call add like this. I just make sure that I always pass in 2 numbers and I won't face this problem. And that's true, but in a bigger project with lots of code files and potentially a lot of people working on the code base, you might sometimes call a function or use some object in an unintended way. And then you could run into problems like this because nothing is warning you that this is not how you should use this function. Nothing is telling you that this function actually wants 2 numbers instead of 2 strings or any values. And that's where TypeScript can help us. Because with TypeScript, and I'll show you this code even though we haven't installed TypeScript yet, but I have it installed on my system already, and we will install it together in the next lecture too. But let me show you this first. So with TypeScript, if I copy this code, what we will be able to do is we can add type annotations here, simply by adding a colon after our parameter, and then adding the type which should be used for this parameter. And I'll do this for B as well. And we'll also not just be able to use type annotations on function parameters, but as you will see throughout this module, we can use types in many other situations as well. So now I'm making it clear with TypeScript that here I actually want 2 parameters which both should be of type number. And hence, I already get an error here in my IDE, which tells me that this argument of type string is not assignable to a parameter of type number. Pretty helpful. And with that, I can catch such an error, such an unintended use of this function before I run and test my code. And that, of course, allows us to write better code in the end, because we can avoid such errors and we don't have to track them at runtime, but we see such errors right when we start writing code. And that's why using TypeScript could be worth a thought.